Be no good. All right. So I already have a video on systems of equations in general. This one I'm focusing on nonlinear systems of equations. It's like one little section of 6.1 that covers this, but they don't really go into a lot of detail. So I figured I'd pick some, kind of explain how I solve these type of problems. So a nonlinear it's just a regular system of equations where you have multiple equations, but at least one of them is not going to be aligned. So you're going to have like maybe a quadratic in there or a cubic. There's going to be some sort of other exponent in there, and that's what makes it nonlinear. Usually, once you have linear systems, there's going to be more than one solution, 2, 3 solutions. It depends on whether you have a quadratic or you have a cubic. And the best way to solve these is through substitution or graphing. The questions on the one question on the final line systems, and I think it might be graphing if I'm recalling correctly, where you see the solution based off of graphing. Some of the systems that I'm going to go through here you can actually do through elimination if it's set up nicely to do that. So I'm going to do some with elimination, some with substitution, and then I'm going to graph these so at least you can verify your solution. So I have 4 different examples that I'm going to go through to show you the different types of solutions you can get from one of these. So here's the first one. We have 4x squared plus x equals 3 and negative x minus y equals 11. So this is nonlinear because one of the equations is quadratic because that has that x squared. So because it's quadratic, we expect to get 2 solutions. Now the way that this is set up, I can actually solve this using elimination because if I add these, my y's will cancel because I have a plus y and a minus y. So that's what I'm going to do here. So I'm going to use elimination set up this way. Now the 4x squared minus x, those are not like terms, so those can't combine. So I have to just write those, 4x squared minus x. But the y minus y is 0, so that disappears. And then 3 plus 11 is 14. So now we have a quadratic. We have only x. So now this is something that you want to solve by factoring or the quadratic formula. So I need to put everything on one side in order to get it equal to 0. So I'm going to subtract 14 from both sides. So this gives us 4x squared minus x minus 14 equals 0. And I'm doing in my head, I'm just kind of thinking, this is factorable. And if you're not sure, quadratic formula will always work, but I've done enough of these that I can look at it, kind of go through a few quick guess and checks and factor. So to get to 4x squared, I'm going to have 4x times x, and then 14 is 7 times 2, and let's see, I want to have a minus and a plus equals 0. So the inside is 7x, the outside here, 4x times negative 2 gives me negative x, 7 minus 8 gives me that negative 1 in the middle. And then I can verify 7 times negative 2 gets me negative 14, and then 4 times 1 gives me my 4 for the 4x squared. So this one was factorable, and it was easy enough that I could do this one. And now we need to solve for x. So I need to set each of these equal to 0 to solve for x. So I have 4x plus 7 equal to 0, and x minus 2 equal to 0. And so now I'm going to solve both of those for x. So I'm going to subtract 7 from both sides for the first one, which gives me 4x equals negative 7. And then when I divide both sides by 4, I get x equals negative 7/4. The second one here, I get x equals 2. Now this is a system, which means our solutions are ordered pairs, so I also need to figure out the y values. So I recommend putting them in the easiest equation that you can to solve for y. Because of the fraction, I'm actually, let's see, square that. We're going to get a fraction in either one, so I don't think one is easier than the other. So I'm going to just use the first equation because it has a positive y and I don't have to divide by anything. So I'm going to plug in, I'm going to start with the negative 7 over 4. So I'm going to plug that into the first equation. So that it's 4 times negative 7 over 4 squared plus y equals 3. Now I'm going to cheat a little bit and do this on my calculator. So I'm going to just simply enter in 4 parenthesis negative 7 divided by 4, close the parenthesis, and square. So I'm going to do that whole thing on the left all in one shot. And then my calculator gives me a decimal. We generally want fractions, and we want improper fractions. So that comes out to 49 over 4. Now I want to subtract the 49 over 4 from both sides. And to do this, I want that 3 to have a denominator of 4. So I would be multiplying it by 4 to get that denominator. So that would be 12 over 4. So I'm going to just change that to 12 over 4 because 12 divided by 4 is still 3. So now I'm going to subtract 49 over 4 from both sides. And then we just subtract the top. The denominator stays the same. So 12 minus 49 is negative 37. So we got negative 37 over 4. Now this does not reduce. So now we have one ordered pair. We have negative 7 comma negative 37 over 4. So that is one of our solutions. And now we have a second solution because we have a second x value, x equals 2. So I'm going to use the same equation. I'm going to plug in 2 for x. So 2 squared is 4. 4 times 4 is 16. So that's going to give me 16 plus y equals 3. And then I'm going to subtract 16 from both sides. We get y equals negative 13. It's always easier when you don't have fractions to deal with. So this gives us an ordered pair 2 comma negative 13. So we have two solutions because we had a quadratic. And so now I'm going to graph this on Desmos. So let me pull up. So we have 4x squared plus y equals 3. And then the second one, negative x minus y equals 11. Okay, so I got to zoom out. So the system, the intersection point, is where. So you can see 2 comma negative 13 is one of our solutions. The other one we had fractions. It was negative 7/4, where as a decimal is negative 1.75. And then negative 37 over 4 as a decimal is negative 9.25. So we can verify our answers by looking at the graph. And you can see that these are the two intersection points where we had a parabola intersecting with a line. And so it crosses it at 2 points. Are there any questions on that example?
No.
Okay. Here's one with a cubic. So I wanted to also show you one with a cubic. So we have 3x plus y equals 2 and x cubed minus 2 plus y equals 0. So this is not set up for elimination. We could do elimination if we multiplied the first equation or the second one by -1. So either one would work, or we can do substitution by solving, I would say, the first equation for y and then plugging that into the second. So would you prefer to do this with elimination or substitution?
Substitution.
Okay. So I'll do this with substitution, and when we use substitution, you want to solve the one that doesn't have the exponent, because that's the easier one. If we try to solve the one with the x cubed, when you substitute that in, it kind of gets a little confusing, especially if you decide to solve for x. So I usually solve the linear equation because that's a lot easier. And because our exponent is on the x, that means I want to solve for y, because trying to get rid of the x when it has a cube is going to be a lot harder than getting rid of the y. So I'm going to take that 3x plus y equals 2, and I'm going to solve this for y so I can substitute it into the other equation. So this gives me y equals 2 minus 3x. Now, in the second equation, I have x cubed minus 2 plus y, and y is 2 minus 3x. So that I don't really need these parentheses that I put in around the 2 minus 3x because there's a plus in front of it, but if there had been a number in front of it or a negative, then I would need parentheses around that. I just put that in there so you can see that's where I substituted, but they're not really needed. Now, when we simplify this, I have my x cubed, and we have 2 plus 2, which is 0, so that cancels, and then minus 3x equals 0. So now from here, we have a cubic set equal to 0. To solve this, we need a factor. So I'm going to factor out an x from the x cubed and the minus 3x. That gives me x squared minus 3 equals 0. Each factor equal to 0. So I have x equals 0, and then x squared minus 3 equals 0. So now you need to solve the x squared. So if I add 3 to both sides, this gives me x squared equals 3. I mean x squared, and I wrote x cubed. Too many 3's there. X squared. Then I take the square root, and when you take the square root, you get a plus or minus. So I get a positive square root of 3 and a negative square root of 3. Now, we got the square root of 3. This is going to be kind of nasty when you try to plug it in to get your other part of the ordered pair, but it doesn't matter because I leave it looking nasty, especially because I've already solved my equation for y. So first off, I'm going to start with the x equals 0, and I have y equals 2 minus 3 times x, so that's 3 times 0. So 3 times 0 is 0, so that's just equal to 2. So my first ordered pair is 0, 2. That's easy enough. Now I'm going to say, let's use the positive version of square root of 3. When I plug this in, I get y equals, for some reason it doesn't want me to draw. There we go. 2 minus 3 times x, and x is the square root of 3. We could just leave it like that because if you take the square root, it's going to get nasty, and they're not really like terms. So you can keep this as, whoops, my x is not 2. Square root of 3, and then 2 minus 3 times the square root of 3. And I wrote a 2. So you can leave it like that. If you wanted to check your answer with graphing, then you would have to find the decimal approximation. And then when we have negative square root of 3, that's our third answer here. The only difference is that instead of 2 minus 3, that negative is going to turn it into a plus. So that's going to give us negative square root of 3 and then 2 plus 3 times the square root of 3. So we had a cubic, and that gives us 3 answers when you're solving. So if I graph this, we had 3x plus y equals 2, so that's our line. And then x cubed minus 2 plus y equals 0. So you can see there are 3 intersection points. So these are the decimal approximations. We have 732 or 7.196, 0, 2, and then basically the same thing but in the opposite sign, a positive version with the negative 3.196. So this would be this would be something that you might want to solve visually because it's kind of hard with the square roots to solve, but you can get the exact answers. It just doesn't look nice because you have to deal with those square roots. But you can verify them by doing their decimal approximation and then looking at the graph. Do you have any questions on this one?
No, I can understand it.
Okay. And you're not going to have to do too many of these. I think a problem similar to this one is the graphing one on the exam, if I'm remembering it correctly. Okay, so here's another one. Now our y is squared, but it's the same sort of process. This one is not really, you could do elimination. You'd have to multiply the first equation by -3, but I'm going to do substitution. And because our y is squared, I want to keep y in my equation, so I need to get rid of x. So I'm going to solve the first equation for x, so that way I have y that when I substitute it in. So the first equation is x minus 2y equals 0. And when I add 2y to both sides to solve for x, I get x equals 2y. So then I'm going to take the second equation, 3x minus y squared equals 0, and replace x with 2y. So then I have 3 times 2y, so that gives me 6y minus y squared equal 0. So in this case, we're solving for y now instead of x. So I can factor out a y, which gives me 6 minus y equal 0. And then even though it's y instead of x, you can still solve by setting each of those equal to 0. So if y equals 0 and 6 minus y equals 0. And for the second equation, if I add y to both sides, that gives me 6 equals y. So now I have y equals 0 and y equals 6. Now I can plug both of those into my x equals 2y equation so that I can find what x is. So when y is equal to 0, x is equal to 2y, so that's 2 times 0, which is 0. So one of my ordered pairs is 0, 0. The second answer we got was y equals 6. So x equals 2y means we have 2 times 6, so we get 12. Now, x is first, so this is 12 comma 6. You want to be very careful that if you end up solving for y first, you make sure you put them in the right order. With the 0, 0, it didn't really matter, but here we found y first, so that's the second value, not the first value. And if I go back to Desmos, so I have x minus 2y equals 0. 3x minus y squared equals 0. And then you can see that they meet at the origin, and then the other point here is 12, 6. So the y squared actually forms a parabola that's sideways. That's what's kind of neat about some of these is the y, when you square the y, it kind of goes the other direction instead of up and down like we usually expect from a parabola. Any questions on this one? Okay. And now this is my last one. This one now we have both x and y squared. So this one's going to be a little more confusing. When you have both x and y with exponents, you cannot use the elimination method. You would have to do substitution. In this case, we're looking at the top equation. I have 2x minus y plus 3 equals 0. I'm going to solve for y. I'm going to do this because it's easier. It's a lot easier to solve for y because all I have to do is add y to both sides. And I've already got x squared and x in my second equation, so getting rid of the y just makes it easier since I already have two terms with x's. So I have my 2x minus y plus 3 equals 0, and I'm going to add y to both sides so that I can get 2x plus 3 equals y. Now I'm going to substitute that in for y squared. So first the second equation is x squared plus y squared minus 4x equals 0. So x squared plus, and then y is 2x plus 3. So that's 2x plus 3 squared minus 4x equals 0. Now you have to square the 2x plus 3. So 2x plus 3 squared is 2x plus 3 times 2x plus 3. So if I FOIL, I have 4x squared plus 6x plus 6x plus 9. So that's 4x squared plus 12x plus 9. So I have x squared plus 4x squared plus 12x plus 9 minus 4x equals 0. So this one's going to be a little more work now because we had to first square our y, and now we have to add our like terms. So my x squared's 1x squared plus 4x squared is 5x squared. Then I have a 12x minus 4x, which is 8x, and then plus 9 equals 0. And now I'm trying to see if this is factorable or if we will have to use the quadratic formula. So let's see. This does not appear to be factorable, so this means it's a quadratic formula problem. Oops. Okay. So x equals negative b. So b is 8, so that's going to be negative 8 plus or minus. Now b squared, so that's 8 squared minus 4 times a, which is 5, and c, which is 9, all over 2 times a, which is 5. So negative 8, whoops, I forgot my plus or minus. Come on. It doesn't want to erase. Don't know why. I don't know why my thing doesn't want to erase. Nope, that doesn't want to erase either. Okay. I'm going to attempt to turn that into a plus or minus because it doesn't want to erase. Negative 8 plus or minus. So 8 squared is 64. And then 4 times 5 times 9 gives me 180. So that's going to be minus 180 over 10, since 2 times 5 is 10. Negative 8 plus or minus. And then 64 minus 180 is going to give me a negative. Negative 116 over 10. Now, as soon as a negative inside that square root, that's going to tell me that I'm going to get a oh, why is that? That's supposed to be highlighting, not completely covering up what I just wrote. It really, I don't know what is going on with my stylus right now. It's really messed up. That's supposed to say negative 116. There. I don't know what is going on there. I'll just cover that up. But as soon as you get an imaginary number because of a negative inside the square root, that an imaginary number you can't graph. And our solutions are graphical solutions. What we get, we have to be able to graph it. So an imaginary number means that there is no solution because we can't graph an imaginary number. So imaginary number equals no solution. So that means there's no solution for x, which means there's no solution at all. So when I graph these two equations, there will be no intersection point. So bring back up Desmos. The first equation was 2x minus y plus 3 equals 0. And the second one is x squared plus y squared minus 4x equals 0, which is a circle. And you can see that they don't intersect at all. So because these don't intersect, there is no solution. And that's why when I was solving with the quadratic formula, I ended up with an imaginary number inside the square root, right? And get a negative inside the square, which is an imaginary number. That's something we can't graph, so there's no solution. So are there any questions on this example? Okay, you guys are pretty quiet. Oh, it suddenly went on my other slide. I don't know what is going on with my thing right now. I will. Oh no, I accidentally discarded all my. Oh no, I discarded all my writing. Shoot, I pushed the wrong button when I. All right. Well, do you guys have any questions?
I'm good.
Okay. Well, thank you guys for joining. I appreciate this. Let's see. Tomorrow, is it tomorrow? I think tomorrow is when I said that I am going to be basically on video. Let me double check. Yes, basically from 6 to 8. So if you guys have questions, since it's, you know, like the end of the course, I'll just be on video here 6 p.m. till 8 p.m. just available for any questions. So you can pop in and out. I'll just be sitting, probably reading discussions or something. Nobody asks questions. So thank you. I hope you guys all had a great Thanksgiving and have a great Christmas coming up. So hopefully I'll see you guys tomorrow with questions. If not, I'm planning on making a kind of a goodbye video or whatever, just to kind of send you guys off. So this has been great. Thank you guys for showing up, and hopefully I talk to you guys later. Bye.